Lesson 11.5. We are doing volumes of prisms. So today we are moving to the world of 3 dimensions. And our answers then, if you multiply, for example, miles times miles times miles, we have miles cubed. Which, if I think about it, this is a little cube, think like a die, excuse me, that is 1 mile by 1 mile by 1 mile deep, excuse me. All right, here we go. Volume. This is the stuff inside. We measure it in what we call cubic units. Maybe we should write that out, units to the 3rd power. All right. And the big formula is find the base. The base is an area, multiply times the height. If you remember nothing else, that's how you calculate volumes. Cavalieri's principle. Italian guy that said, if you stack a bunch of coins on top of each other, and then you tilt those coins so that they are off at an edge, at an angle, I should say, okay? So the 4 coins, instead of being vertical line, we don't change the volume. Volume stays the same. So volume equals volume. So just because you change the angle doesn't change the volume. All right, density. We've come across some density problems already. Density is where we divide. Whatever it is, maybe it's the mass, maybe it's the number of people, okay, by a particular volume that we've calculated. All right, and that tells you how dense something is or not. Volume of a cylinder. So how do I find the volume of a cylinder? We take the base times the height, where the base is the area. I'm going to color that base in there. Yeah, so this is a 2-dimensional, and h is the height. To find the area, you need to use the radius, oftentimes. So if it's a cylinder, then it's pi times r squared. There's my circle times the height. And again, this is Cavalieri's principle. If you have the same height, even if it is bent, you're going to get the same volume. So the volume will be base times height in both those cases. Prism. So again, whether it's a prism or a cylindrical shape, you got the same idea. So I have a base. In this case, my base is rectangular times the height. So the way we write that out typically is you can think of it as length times width. There's your base times the height. And B is the base of the shape, 2D. And H is the height, linear. All right, here we go. Oh, one more thing, similar solids. If you have 2 solids that have the same, they're the same type, okay? And they have the equal ratios. So for example, if I build another little tetrahedron over here, smaller one than the one that's given to me, and I know that, I don't know, let's go 10, and let's say this side is 6. And then I know that if these are similar, then I have a scale factor. Remember scale factors? In fact, let's not put that here. Let's put that up here in the definition. We use a scale factor, and we refer to that scale factor as K. So that's why we have K going here. And you recall from chapter 7, 8, that the scale factor is or 10 over 6. You remember how to decide which one it is? Well, since you're going smaller, you want to pick the number that's less than 1. All right, so that's a review of chapter 6, scale factors. Now, volume. How does the volume of the first one compare to the volume of the second one? The mistake some kids do is they say, oh, I know, I'm just going to take 6/10 times that volume. And if this was a line, that'd be fine. But since we're dealing with a three-dimensional shape, we have changed each of these 3 dimensions. So that power becomes a 3. All right. So in general, if you want to multiply to get the new volume, you have to multiply by the whatever the scale factor is to the 3rd power. So that's going to be a little bit tricky. Find the volume of the prism here. Number 1, we have a volume, and I have the base is here. Some kids think the base is down here, this piece. No, that's not the base. Why? Because that base doesn't stay constant. If you look at this base, however, though, no matter where we look in the triangle, we have that same triangle, correct? All the way back. So find the area of it, the base, times the height. In this case, the height is 5. How do I find the area of that base? Well, it's a triangle. All right. We know that the height of this triangle is 1/2. So the area of a triangle is equal to 1/2 times 3 times 1.5. Hopefully you've got a calculator and you can multiply that out. I think you're gonna get 2.25 exactly. So times 5, I think gets you 12.25 centimeters cubed. Yay, don't forget cubic units. Simpler problem. It looks trickier because we now have an angle. This is a tilted tower. It is, though, the base is down here, and that base stays constant all the way through to the top. So we can say volume equals base times height. So the base in this case, they already tell me, yay, it's 10. I don't need to figure it out. Height, 4. So my volume is 40 inches cubed. So easy. Oof, number 3, also a cylinder. A prism, sorry, right? Got a base. Got to figure out that area, and then multiply by my height. They give it to me. So the volume equals, again, the base, pi r squared, times the height, 7. So I've got pi, and the radius looks like it's 2.5. So I'm going to square that result and multiply by pi and multiply by 7 on my calculator, because I can't do that in my brain. All right, pi times 2.5 squared times 7. All right, and in approximated form, rounded to the nearest tenth, I have 137.4 inches squared. Whoop, not squared. Bad habit, inches cubed. Volume of my cylinder, volume of my prism, volume of my Triangular prism. These next few problems now have us kind of like either think about things abstractly. So here we need to find the height. We're not looking for the volume. They give us the volume. So again, volume equals base times the height. Remember, the base is a two-dimensional shape. So what is the two-dimensional shape? Well, it's a circle. So that's pi r squared. The height. And the volume is 2010. So where does the 8 go? Well, the 8 goes in for the radius. So I have 2010 is equal to pi times 64, because I square the 8, times h. Our job, solve for h. How do I get rid of the pi and the 64, you ask? Just divide. So I'm going to take 2010 divided by pi divided by 64. Make sure you use parentheses on this. It's easy to make a mistake if you don't. So the height is 9.9969. So rounded to the nearest tenth, I get 10 inches tall is my height. So this one here, it says find the area. Area of what? Area of the base. Again, volume equals, hopefully I'm sounding like a broken record. They give us the volume, 50. I need to figure out the base. Oh, they give me the height, 7.5. So simple, right? We just take 50 divided by 7.5, and we get a base of rounding to the nearest tenth, 6.7. I look for my units, centimeters. Squared, almost forgot, because it's an area. Let's not actually find P. Let's not worry about that. Let's create a ratio problem. Another little cylinder that's similar, and let's find, let's use a K value of 2/3. Okay, so we're making this 2/3 smaller. All right, radius is whatever the radius is. Let's figure out now what the new height of it would be. Well, I need to make it smaller, so I'm going to multiply by 2/3, and that's going to give me 4, I think. Check it on your calculator, but I think we got now 4 inches. What's my new volume? Here's the mistake kids make. Again, volume is 75.36. Multiply by 2/3. Whoa, hang on, we had to multiply by the volume cubed, yeah, to get the new volume, because this is a three-dimensional shape. This, what we started off with, was just a one-dimensional piece, so that's why we just multiplied by k. But now I need to multiply by k to the 3rd power. Okay, so this is 2 times 2 times 2. I have 3 2's upstairs, and I have 3 3's downstairs, because that's what 2 cubed and 3 to the 3rd mean. All right, so 75.5636 divided by 3 times 3 times 3. Okay, I got the new volume to be drastically smaller, 22.3 inches cubed. Okay. Well, best of luck in your homework as you go through and do those volume problems. Sometimes you got to find a piece, kind of like the height or the P, the perimeter. Work through it carefully.